Good evening, students. In yesterday class, we discussed about the congruent melting points. You need to basically real. In today's class, I am going to discuss about the two component system, application of the component system. It undergoes the congruent melting point. I give an example for congruent melting point yesterday. In today's class, phase diagram of ferric chloride water system. Phase diagram of ferric chloride, phase diagram of ferric chloride water system. Phase diagram of ferric chloride and water system. Can I draw phase diagram of ferric chloride and water system? Minus 20 minus 40 this is a minus system. And here 20 40 80 and 20. This point is A. Yesterday I discussed this graph. Here first is comes here and this one and this same graph this one. This is this point is A. This according to this composition, according to this axis composition, according to this axis temperature. Here this is a 0 degrees Celsius. A and B. This is the C. This is E. F. G. H. J. K. L. This point is L. And here this is a and this one is B. This is B here. This is a B here, and this one is C. This point. This one is C. This is coincident line here, and one is horizontal line. This is a vertical line here. This coincident line. This is a C. Yeah, this is a small c. This is a capital C. Don't confuse capital C and small c. Here, this coincident line. This is a small c and this is a capital C. Okay, this is A, this point is B and this point is C and this point is B. Small b and this point is E and this point is F. A, B, C, D, E, F and this point is EF. A, B, C, D, E, F and here G, C complete here. This point, this coincide is a F and this is a G and this is a H, J and this is K and this is F. This is a small level. This is also small G. This is also small K. J, K. Here A, B, C, D, E, F, G, H, J, K, L. Or you can take I also. You take an I. This is a L is not here. K is L here. This is a minus this point minus 55 degrees Celsius. And this is a hydrated ferric fluoride. Fe2, I write here, Fe2, Cl6, 12H2, 12H2O, and this line, and this line, Fe2, Fe2, 7H2 and this one is Fe2 5H2. This one is Fe2, so here Fe2Cl6, Fe2Cl6 7H2. Here Fe2Cl6 5H2. Here Fe2Cl6 4H2 and here Fe2Cl6 anhydrous solid Fe2Cl6. Finally, the formation is Fe2 This is a unsaturated. This here, the above here, unsaturated. In our examination, draw. This is a neat labeled diagram. This is very neat diagram. To draw a neat diagram, you get some marks here. This and if you explanation on this according to this diagram, you get a full marks. Okay, unsaturated solution. Unsaturated solution. X is equals to Fe2Cl6. This is a X12H2. I written X means here Fe2Cl6. This is X7H2 and this one X5H2 and this X4H2. This is a phase diagram of ferric chloride water system. FeCl3 H2O system. This is okay. Here, this is the phase diagram for ferric chloride H2O, ferric chloride water system. Here in this is a two component system. Here with congruent melting point. This is two component system with a congruent melting point. In this system, here in this system, the two components are present here. The two components are present, namely one is a ferric chloride and another is a water. One is a ferric chloride, water. Two components are present. This hydrated with, it is one react with one another. This is FeCl3 water and to form a hydrated ferric chloride. Here the four hydrated solids are formed here. The four hydrated solids are formed. One is this Fe2Cl6 12H2O. Here I taken this FeCl3 is a double because of here it avoid the water molecule. I am writing I know water molecule is in a fractional. This I taken only single FeCl3. The water molecule write in fractional because of the fractional values I avoided because of I taken a double of ferric chloride. This is a Fe2Cl6. This Cl3 Fe is 1, Fe2 I take here Fe2Cl6 12H2O 1. This is a ferric chloride dodecahydrate. This is a ferric chloride hexahydrate. This is a ferric chloride pentahydrate and this ferric chloride tetrahydrate. These four hydrated ferric chloride are formed. Here these two components are reacted form these four solid form of hydrated ferric chlorides here. It is the fractional. It is for fractional value of crystallization is avoided. Here, water molecule. Each hydrated possesses a congruent melting point to go a liquid to the same composition to give a solid in the same composition of a hydrated in this solid phase. And here beside the above four solid phases, here the above the four solid phases, and there are two more solid phases. One is a ice here, namely that is of Fe2Cl, this anhydrous Fe2 ferric chloride, and another is a ice, and in liquids as a solution, and another in solid as a in gases as a vapor. Here vapor is negligible here because of the pressure is kept at a constant. You used the reduced phase rule. F dash is equals to C minus B plus 1. You are using this reduced Gibbs phase rule equation here. And here there is a 7 possible phases are present in this. In the different phases exist in a equilibrium under different conditions. Here equilibrium, you know equilibrium, this is equilibrium, and here this is in equilibrium, this curve is equilibrium, this point is in equilibrium. This is a in equilibrium. They exist in a different under the different conditions. So temperature and composition. Here the temperature, different conditions of temperature and composition. Here this is one different composition, this is a different temperature, and this gives a different composition and different temperature. This different temperature and different composition, it get a equilibrium condition. And this is a phase diagram for ferric chloride and water system. Here for one more, here the capital letters lie on a curve, while the capital letter, the point of capital letter, points corresponds to this capital letters A, this B, C, D, E, F, G, H, J, K, L. These are lie on the curve, while the points corresponding to small letters, these A, B, C, D, E, F, G, H, J, K, L letters lie on a horizontal line. This is a horizontal line. And this is note for you. Small letters and capital letters. We have this here and this here. The small letters. First, I consider first one curve AB at point B. Okay, consider here and here. First point, curve AB, this curve AB at point B. Okay, here the point B is a eutectic point or eutectic temperature. This point eutectic temperature, and here eutectic composition. This is a eutectic point. This is here in two component system use the eutectic point. Okay, here I consider this point here. This is a this A is represents here. The point A represents the freezing point of water. This A is a freezing point of water, and here this curve AB represents the freezing curve. The freezing curve of water. This AB curve represents freezing point of water, which increase the amount of ferric chloride. Here this ferric chloride, the adding the amount, it increases the amount of ferric chloride in have been added here. You are see here. This is a container. This is a container. You are added in the water as a solvent here. The water solvent is added. This is in liquid state. And here, according to this point, you are this is cooling here. The dry hydrate. You are doing dry hydrate. This at 0 degree Celsius. This is a freezing point of this A, and here this is a freezing point of this static temperature. This is a minus 55 degrees Celsius, and here you are adding this is water. You are decreasing temperature here, and you are adding the FeCl3 here. FeCl3 solid, and the FeCl3 decreases the temperature here. The FeCl3 decreases, it freezes here. The form separates here. A is the solid. Ice is separating starts here. The point is touch here, and the composition changes. Next point comes here. The composition changes. Next point comes here. They finally reach the point B. And here the solution is saturated, and the B is a cryohydric point. This point is known as a cryohydric point, or a eutectic point, or eutectic temperature, or eutectic composition. This temperature is minus 55 degrees Celsius, and this curve is known as a freezing curve. Because of you are decreasing and adding the FeCl3, the temperature is decreases. According to this curve, the gradually decreasing, and they reach the point, this point, and this point is a eutectic point, and they start another new compound, new solid compound. Here this is a Fe2Cl612H2O, the ferric chloride of dodecahydrate. This is start separating in this equilibrium. This data equilibrium one in here, three phases in this point, three phases are present. One is a this solid A, so this water is ice here, and another is a solution, and another is the formation here. Fe2Cl612H2O is present here. This is also start the new compound. New compound is start forming the solidification here. The presence of this point B is known as a eutectic point. Eutectic point. Here B is a eutectic point, D is a eutectic point, F is a eutectic point, and H is a eutectic point, K is a eutectic point here. And then here there are three phases are present. You apply on this line curve AB curve. Here F dash is equals to C minus B plus 1 is equals to 2 component system, minus B is a three phases here. One is solidized and another is a liquid state because of liquid. Here liquid and FeCl3 is present here, and in liquid state water and plus FeCl3 in liquid state, and another separating the ice here, and another is a new formation solid, this Fe2Cl6H2O. The presence of three phases here plus 1, therefore is equals to how much degree of freedom? The presence of variables here 0. 2 plus 1 3, 3 minus 3 is 0. This is a non-variant in nature. This system is a invariant in nature or a zero variant in nature. The system is a zero variant. And this point is known as a eutectic point. And next I consider second one. This is a freezing curve. Next, second one, curve B. You come from here, you have changing the temperature here, the curve B curve BC at point C. At point C. This point C is known as a melting point, congruent melting point. You know what is congruent melting point? In same composition, it suddenly changes in liquid state, it suddenly changes in solid state. When this C point this comes lower, this line lower with this line, it suddenly all the compound, the all solution converts in a solidification, a solid phase in and the above the line here 1 degree Celsius or here the composition is same here and temperature is same just a fraction here and whole liquid is converted in a equilibrium and solution is saturated and this is a Fe2Cl6H2O. In these three phases, one is solid Fe2Cl6H2O, another is a solution and here the vapor phase and vapor phase is negligible. The presence of two, one is it is sudden changes in liquid state, it is sudden changes in solid state. This curve is known as this BC curve. This BC curve is known as the solubility curve of this Fe2Cl612H2O. And this is a curve BC represents the solubility curve of ferric chloride and hydrate. Here at this point the saturated solution has the same composition that of the solid Fe2Cl6. The point C represents a congruent melting point. Here this C represents the congruent melting point of this Fe2Cl6H2O. You see here. This curve is a freezing curve. You are freezing this water molecule, freezing curve, and this is a solubility curve. This is a solubility curve of this Fe2Cl612H2O. And here this point C is a here congruent melting point. Here this is presence of here two, one is solid, one is a liquid, and the one solid liquid and apply the reduced phase rule. Here F dash which equals to C minus P plus 1. Here two component minus 2 plus 1. Here this is a univariate. Here two component system and this curve here, this curve is two component system and two phases plus 1. The curve is univariate. All the curves here, AB curve and BC curve, CD curve, DE curve, EF curve, they all the curve here univariate. Here the system is univariate in nature. This curve indicates the solubility curve, this BC curve. And next I consider the curve CD, this curve CD at point D. Third one, curve CD at point D. You know, similar here, AB, BC. Here CD, DF is similar, and EF is similar. EF and this AC and FG and this GC and this GH and this AB and this HJ and this BC and this JK, this AB and this KL and this BC. This is a similar curves here. For I consider that is a curve CD at point D. Curve CD on here on further addition of here the FeCl3 ferric chloride and here the further addition of ferric chloride and here depresses the melting point of ferric chloride dodecahydrate here. This is the depresses here the lower the melting point here. This is the and the another at this point the another this is a detecting point. Another new solid compound is formed here. This is a Fe2Cl6 7H2O. The ferric chloride hexahydrate is formed here. Also three phases are in exist in equilibrium and this is known as a eutectic point here. And same here the degree of freedom is 0. Here they already applied a reduced phase rule for this phase rule. Here the F is equals to 0. One is a this solid Fe2Cl6 and another is this Fe2Cl6H2O and another is a liquid in state and this is also known as a transition point. This is also known as a transition point. I choose the transition, the converting here Fe2Cl6 12H2O to this one transition Fe2Cl6 7H2. Because of transition takes place, the ferric dodecahydrate to ferric hexahydrate. This represents the change of. This is the representative of change of this. Because of this is known as a transition point. This is also known as a transition point. Next, curve E of this CD curve is completed and next DE curve. Fourth one, DE curve at point E. Okay, this is a DE curve at point E. Here, like this curve BC. This is same. DE curve. This is a similar for BC curve. And the curve EF is the melting curve. Here, the curve EF is the melting curve of this ferric chloride 7H2O and point E is the congruent melting. You will see here this point E, C is the congruent melting point, E is the congruent melting point, G is the congruent melting point, J is the congruent melting point. And these are the eutectic points, these are the congruent melting points. Here this is in equilibrium. Here the E is the congruent melting point. The formation here, this Fe2Cl6H2O, and this is in the univariant, and this is a univariant in nature. Here also congruent melting point of Fe2Cl6 5H2O. Next, so this is the congruent melting point of this 7H2O. Next, the curve I consider DE curve at point E. Next curve EF curve at point F. Next, fifth curve EF curve at point F. You write down same curve AB, point B, curve BC at point C, curve CD at point D, DE point D, EF point F, FG point G, GH point H, HJ point J, JK point K, KL point F. This is a, you have to write the curves here, similar structure, similar explanation here, and here the formation is changes here. The solid formation in this dodecahydrate, in this region the hexahydrate, and in this region pentahydrate, in this region tetrahydrate. The final formation is anhydrous chloride. Okay. Now consider EF curve at point F. EF curve at point F. Like curve CD, here the same point here, the curve like this, like the CD is a similar for this EF curve, and here the EF curve, the melting curve of this 7H2. This EF curve is a melting curve of 7H2O. This CD curve is a melting curve of this 12H2O. And this GH curve is a melting curve, melting point of this melting curve of this Fe2Cl6. And this is a Fe2C, melting point of this Fe2Cl6 4H2O. Okay, F here, the F is a triple point, that is a eutectic point. The presence of this Fe2Cl6 7H2O and the new formation solid is Fe2Cl6 5H2O. Another is a liquid because it exists in three phases. The three phases are existing in equilibrium, that is known as the eutectic point. And here also you write a transition here, Fe2Cl6 7H2O to Fe2Cl6 5H2O. This is also known as the transition point. Transition point means the here Fe2Cl6 7H2O and Fe2Cl6 5H2O. Next curve, this EF is completed. Next FG curve. Here FG curve is obviously the solubility curve of Fe2Cl6 5H2O. FG curve, the solubility curve of this, and here also same, and this is a point. G is the congruent melting. In explanation, you have to write G is the congruent melting point. This is the solubility curve, and formation is easy to finish. And next, this GH, and GH at point H. Curve GH is melting curve of this one, Fe2Cl6 5H2O, and H is a transition point here. Same explanation, transition point, and where here the new solid is formation. This Fe2Cl6 4H2O in GH, and here three phases are present. Exist in equilibrium state. The degree of freedom is F is equals to 0. And next curve, next HJ and the point G. This HJ and the point, the solubility curve of this one. Here, this is a solubility curve of Fe2Cl6 4H2O. This Fe2Cl6 4H2O, and this J is a congruent melting point. Congruent melting point of this Fe2Cl6 4H2O. This is a HJ curve at point J. And next JK curve. JK curve at point K. Point K is a transition point. Transition point, you have to write transition point here. Fe2Cl6 4H2O, formation of Fe2Cl6. Here JK curve is a melting point of Fe2Cl6 4H2O, and the point J is a point JK, the point here. Are you ठीक? XJ and JK. Let's say here non melting point and you take a point next. J, K at point K, the curve melting curve of Fe2. This K melting curve of Fe2 CH4H2O and the point K is a unhydrous of Fe2Cl6. This unhydrous Fe2Cl6 is from new solid is separates and that point K is also is known as a triple point or a eutectic point or a eutectic temperature or eutectic composition. Okay. This is also transition. Transition here this. Okay. Next, finally, the curve KL. This curve final. This is a KL curve, and it is simply the solubility curve of Fe2Cl6. This is a Fe2Cl6 anhydrous, the solubility curve of anhydrous ferric chloride. This is the explanation of this ferric chloride and water system. We have some and these lines, these dotted lines here. You see here first. These are the freezing curve and these are the solubility curve. These are the melting curve and this is melting curve, solubility curve, and these are the freezing curves. Okay. Next is isothermal evaporation of an unsaturated solution of ferric chloride. Here we consider the FEC. You consider this FeCl3 ferric chloride water system on the behavior of evaporation of saturated ferric chloride solution. It is the evaporation of saturated ferric chloride solution at constant temperature can be here at constant temperature and the unsaturated solution at a temperature between the points of E and F. Here this the temperature between E and F there that is a 31 degrees Celsius. Here the temperature between these 2 points the E and F here it evaporated as 31 degrees Celsius, the evaporated constant temperature and such a solution is represented by initially the point A. This is A and it is gone along with the horizontal line. Then the solution is heated and the solution is heated, its line is goes on to horizontal line. It evaporates and path AL up to A to L. Here the part is along the followed the horizontal line. The evaporation at 31 degrees Celsius. What happens here? The heating takes place. Here heating takes place along the path is followed by this horizontal line A to L and the some points here A to B, B to C, C to D, D to E and E to F, F to G, G to H, H to J, J to K, K to L here. Okay, first one, the concentration of the solution increases. Here you are moving A to B. Here the concentration of the solution increases till the point B. Up to here the concentration is increases. Point B, the solid Fe2Cl612H2O, solid Fe2Cl612H2O begins to separate out. Here starting is separating this ferric chloride hydrate. And the second point here, this after here I will deduct the explanation of this A to L. Second point is heating behind the point B, your evaporation, the water is evaporation takes place. Here the water is evaporated and the temperature increase, finally form the anhydrous ferric chloride here. Behind it, at First, behind the point B causes more and more water to evaporate off, and this is start more hydrate Fe2Cl6 and separates out till point C where there is only a Fe2 12H2O is separated. When this point C is reached, then point heating behind the point C is reached causes water come off the hydrated FeCl6 Fe2 7H2O here, and next it is reached this point and formation here for Fe2Cl6 4H2, and then it is when the water is completely evaporated. The finally formation is ferric chloride, anhydrous ferric chloride. It is anhydrous ferric chloride salt is formed. Up to here you have to write in your examination. You get a 4 to 5 marks. In this question 4 to 5 marks, this is a very important 4 to 5 marks. We label this is a melting curve and this is a solubility curve. Those are congruent melting points. Congruent melting points. These are the congruent melting points, and these are the eutectic points. What you can take composition, what is it, on which axis is taken composition and which axis is taken the temperature and what happens in temperature changes, and you are depressing. You have to write on curve AD, curve BC, curve CD, curve D, and formation of those four hydrated solids, and finally form the anhydrous Fe2Cl6 salt. This is a complete explanation of ferric chloride and water system. Can continue in next class.